We are very pleased to welcome Dr. Mike Daly from Facebook or Meta. He's a senior research scientist in the core data science team, and his group is working on creating the Large Hadron Collider for social networks and use it for all sorts of cool things. In fact, he focuses on social networks and economic opportunity, including migration, health, education, and social capital. And his work has been featured in top scientific journals, including Nature, Journal of Political Economy, and has also been covered by major media outlets like The Economist and New York Times. So I'll let Mike talk about his really cool work at the scale that I can never imagine that he's able to do. And so welcome, Mike. Thank you so much for accepting our invitation and presenting us today.
Thanks, Ankur, and thank you all for the kind invitation to let me come talk to you. Really excited to be here. I wish I could be there in person, so that'll have to happen next time. I'll have to relearn how to shake hands and say hi to people. I heard that you all had Paul Milgram speak in your last version of this session. So good to hear that you keep, getting higher profile speakers and better speakers as the year goes on. Paul was actually my micro teacher back at Stanford. And, while economists say that correlation doesn't equal causation, the fact that I took his class and then he won the Nobel Prize, you can't rule out that that wasn't causal. So I dare you to rule that out. But I hope this will probably be a very different talk than the one Paul gave, since I'm more of a descriptive economist than a theoretical one. So yeah, as they said, I work at Meta and I do a lot of work on social networks. And today I want to talk about the work we've been doing on measuring how social networks are related to economic mobility. All right, there we go. So here's a map that not many people know, and I feel like everyone should know this map because I find it so fascinating, so cool. So this map is called the Descriptive Map of London Poverty, 1889, created by a man named Charles Booth. And the issue was Charles Booth was a businessman living in London, and he was involved in a lot of policy debates about how to help the poor, what are the right policies to put in place in London. But there just wasn't good data on who are the poor, where do they live, what were their problems, how can we help them? And so, lawmakers had all these crazy solutions, and he felt like they didn't have the data to know which one should work. So he, in a very businessman entrepreneurial approach, gathered a team, canvassed all of London for 2 or 3 years, knocked on every door they could, and just asked a bunch of questions about what is your current life situation? Are you working? Have you been to prison? Do you have anyone in your household who's been to prison? And then they just mapped all of this data onto a map of London and got these very precise estimates of the poverty rate. And you can see his classification ranges from the lowest class, vicious, semi-criminal, and very poor, casual, chronic want, all the way up to upper middle and upper classes wealthy. So even back then they had casual as an insult for people. So, when you use the word, call someone a casual, it's 1880s London term you're using. But what was fascinating is they found that a lot of people living in poverty were the elderly. They found this large class of people living in poverty who couldn't work, who were too old to work, and had no means to support themselves, and were basically living on subsistence wages and help from people that basically help from charity. And so because of that, they implemented a bunch of social support laws and pension laws to help those who couldn't work anymore and were too old to work. So this, in my mind, is the start of this field of geographic ethnography, of taking data, building maps of the world, and using it to influence policy. And so I deeply believe that there's a lot of important work to be done of just better understanding the world through data that will influence how we can better the world and influence policymakers. And that's been kind of a big motivation for the work I do of social networks. We just lack a lot of social networks data. And I feel like by doing more understanding of social networks, we can better understand policies and what policies we should implement. So one example of this is a project I worked on called the Social Connectedness Index. And the way the Social Connectedness Index works is we take Facebook data, so imagine Facebook friendships or connections or messages, and we look at the strength of connections between any two regions in the world. So this is a Social Connectedness Index for the US, zoned in on San Francisco County, California. The darker regions mean more social connections. And you see that San Francisco is much more highly connected to the surrounding counties, much more connected to most of California and the West Coast, and then a lot of connections to places like Chicago, New York, the Northeast, than it is to say like Alabama, Louisiana, or the South. It surprised us how connected San Francisco was to Central California, which is a very rural place, very different than San Francisco Bay in almost any way. Like it's the middle of California is much more like the South than it is the West. And we were surprised that it was way more connected to the middle of California than it was to a place like New York. So it kind of told us like geography matters so much to the patterns of social connectivity. This is what the data set looks like internationally. So here I have Spain on the left and France on the left. And you'll see that Spain has a lot more connections to areas through which it shares a, there's like a large history of colonialism, and there's like these like language connections. So Spain is very connected to places like in South America, like Honduras or Paraguay, whereas France has more connections to, of course, the like French-speaking regions and former colonies like Guadeloupe and Martinique. So when you look at the Social Connectedness Index data, you can see all these patterns of shared cultural history, patterns of like, colonial history, even migration history. Like if you look at counties in the US that had migration waves in, let's say, the 1900s from, take a place like Norway, you'll see more connections today between that county and Norway, even though that migration wave might have been very localized and was 100 years ago. Like it still shows up in the data today. This data is, by the way, fully open to the public, so any of you can go and download this data and play around with it. This is like another map of like the share of friends living within 100 miles. You'll see that most social networks are deeply concentrated geographically. So location matters. Most of your friends live nearby. Geographic and political boundaries matter. They influence the patterns of social connectedness. And then we found this strong homophily effect at the county and region level. The two counties with more similarity by ideology or income or race had far more friendships than if they did not. So this kind of led us to a pattern of research questions to think about. So one is, what are the economic consequences of geographically concentrated networks? Do we see these at the individual level? And then what are the economic consequences of it? How segregated are social networks by income or class? Do these geographic networks lead to networks that are more segregated by income? Who has access to the most resources in their network? That's another way of saying that, who has social capital. So who's connected to the people who can give them job opportunities or help them in some way? And then does your social network impact your economic mobility? So what are the sort of overall economic consequences of segregation in networks? So at a high level, are networks segregated? What does that mean for economic inequality or economic mobility? And sort of this idea of like, can you network your way to poverty, were what we wanted to study. So sorry, I don't list the team here, but we teamed up with a large team, including Raj Chetty, Matt Jackson, Johanna Strobel, Teresa Kukler, a large number of RAs at Opportunity Insights, and then a few of us at Facebook to study this. And most of our data came from de-identified Facebook social network data, including friendships, demographics, group membership, and location. And then we use supplementary data sources like census data on incomes by block group, rates of economic mobility, and other outcomes. And we formed this sample, mostly consisting of Facebook users between 25 and 44 years old. We also had a smaller sample of teenagers that I'll talk about later. And then we graphed the network between them. And sort of the idea is take these users, take their network, label people as using like age, gender, some inferences like socioeconomic status, and then understand the inequalities in the social network linkages. We also have a sub networks we looked at, like we had a close friend network where we restricted the top 10 closest friends based on proxies for strength of friendship. We also looked at things like family networks. We have parent-child linkages where we linked about 15% of people in our sample to parents based on self-reports or other data we had. To measure socioeconomic status, so a big part of this is we want to understand how are the rich and poor connected in different areas. So to measure SCS, we basically did three things. So first is we took a sample of users who had location history, which is a setting in the app in their phone, which let us collect location information. And then we could assign them income based on census block group information from the American Community Survey. And then based on that data, we could make a prediction for everyone else using a bunch of data we had about them, including their age, their gender, their zip code, Facebook tenure, phone model, to see if they looked like people who lived in high income areas, like our smaller location history sample. And we trained a gradient boosted decision tree model estimate on that first sample to predict the SCS for everyone. And then for everyone, we basically gave them a ranking in the national income distribution. And that is how we ended up with the predicted SCS rings for everyone. So at a high level, it's for some users, we had very granular home location. We then matched that to data on the income for people who live in that location. And then we used that to train a model for the rest of the Facebook sample. And that got us an SCS rank 1 to 100 for everyone in the sample. And so the first question I want to ask is, how segregated are social networks by socioeconomic status? Are users with a higher SCS, are their friends higher SCS on average? So the answer to that is, you're not surprised, I'm sure, is yes, there is segregation in social networks by income. Users with a higher SCS, friends have a higher SCS on average. So the way to read this is at the top, if their own SCS rank is in the top percentile of the income distribution, their friends are about in the 85th percentile on average of the income distribution. Whereas users in the bottom percentile, their friends are about the 20th percentile on average. And the correlation is about 0.5. So there's about a slope of 0.5 in this graph. So for each percentage point increase in your own SCS rank, then the average rank of your friends will increase by about a half of a rank.
So
Go ahead.
Yeah, question. So it's on the previous slide, I guess. My understanding, you're saying that you don't have any information about the individual socioeconomic status, and so you're inferring it from where they live, as well as a limited set of activities on Facebook, and some basic demographics like age and gender.
That's right. So there's a sample of users for whom we have precise location history. So we know essentially where their residence is, right? We know their like home location. I know what your census block is. We match that to ACS data. Also, I believe we also use some tax data that has an income distribution for people in that census block group, right? So it reports the median income and then the variance in that income. So what we do is we can assign those users either the median income of that census block group, or we could also just like randomly pull from that distribution that comes from the public data. So there's some set of users for whom we feel like we observe their true location, and that gives us a good estimate of of either their income or their SCS. I think it's better to think about this as SCS, because you could have like a college student living in a very rich neighborhood, and their income might be low because they're a college student, but the fact they live in that rich neighborhood probably signals they are a higher SCS given the neighborhood they live on. Like America is so segregated residentially that usually where you live is equivalent to SCS in most cases. This might not be true in other countries, but at least in the US, given how much your neighborhood determines SCS, this could matter a lot. Now, there's certainly places in the US where like you might have a census block with like very high and very low people in SCS living in the same census block, and where like the ACS and tax data show like a much higher variance in the income. And so for those users, like, there's going to be some like issues of just like assigning them the median. It's not as bad as if we only had zip code. If we only had zip code, then this would, I don't think we can make this assumption. But given for these users we observe, often their census block, we usually have for a lot.
Because census block is much smaller than, say, zip code.
Exactly, yeah. There's usually a pretty tight distribution on income within a census block. So for most users for whom we observe this, we get a very, now this screen, we talk about LS users, 50% sample. In the actual paper, it's like we have for location history users, I think it's more like 20% of the sample for whom we observe a very fine-grained census block. And so then you can think of that as like our like, I know you call it machine learning, like your golden truth sample, your like training data set. But from that, we then take the rest of the users for whom we don't observe their census block. We only observe things like zip code, phone, et cetera. So we train our model based on those for whom we know their location precisely. And then we build that model, and then we can use that model to make a prediction for everyone else for whom we don't observe a precise location. So the features that end up being the most important are zip code, phone, donations activity on Facebook, like age, gender, Facebook tenure and usage, the things I list here. There's like maybe like I think on the order of 40 to 60 features in the model, but those are the ones that end up being the most important. You can think of it as like, for people whom we don't observe census block group, we do observe zip code. So we observe zip code for everyone. But within zip codes are so large, there could be like a rich and poor neighborhood within a zip code. So the model lets us say like, well, we know you have an iPhone and you give to Facebook fundraisers, so you're much more likely to live in the like rich neighborhood of your zip code than let's say the user who has a low-end Android and is like 20 years old and does not have any donations activity.
Okay, thanks. That's really helpful, because I just think understanding this process you went through a little bit better makes it easier to then interpret what you
absolutely. Yeah, this is pretty critical to the whole paper. So understanding how we did it, the whole thing unravels if like this doesn't work. So yeah, then we get this model. So we have an SCS rank for everyone, and then we can do this analysis of own SCS versus friend SCS. So one question we had is, so this was a sample of adults, is how early does this segregation start? Like maybe for kids or teenagers, they're friending at random from school, and it doesn't matter what their SCS is, their friends look random. But like when they go to college, when they start working, then this graph starts to tilt and slope up. And like maybe the older you are, the more sloped it is. So we took a sample of teenagers and who were linked to their parents, and then we looked at their parents' SCS rank versus the SCS rank of their friends' parents. And this is what that graph looks like. And so what we found is for teenagers, there still is segregation by income. And the slope is about 0.3. So it's not as about 1/3. So it's not as extreme as the 1/2 we found earlier, but it still is pretty homophilous by income. For the teenagers in the top percentile, their friends are about in the like 72nd-ish percentile on that. Their friends' parents on average are on the 72nd. whereas in the bottom percentile, their friends' parents are in about the 30th-ish percentile. So these processes occur in high school too. So this led us to a lot of other questions to answer, which is one is, why do the poor have much fewer high SES friends than the rich? And what we do is we take a look at a lot of factors like geographic factors, where friends come from. And to make this a little easier, we divide everyone into either you're above median or below median SES. So are you percentile 50 to 100 or 1 to 50, just to make some of the analyses a little more easily graphable. But we do a lot in the paper where we don't have this disaggregation. And so the way this looks is, if you take everyone who's a below median SES, then about 32% of their friends are above SES on average. And if you take everyone who's above median SES, about 72% of their friends are on average. So that's just like the two-point version where I take the average of the left and right side of the previous graphs and show what it looks like. So I think the question is, why is there this huge gap? Why are below median SES friends not making friends above the median SES line? And we kind of want to like dive in and like decompose where that gap comes from. This is what, if you just take that blue 32% bar and you graph it around the US, this is what it looks like. And so you'll see that there's places in the US concentrated in the South where if you're below median SES, then a much smaller percentage of your friends are going to be above median SES than other parts of the country. Like, some parts are below 20%, 10%. Meaning if you are poor in those areas, most of your friends are going to be poor. Whereas there are other areas like, Minnesota, the Midwest, Utah, Seattle, where for a lot of places, if you are below median SES, a lot of your friends, you will have a much higher percentage of your friends who are above median SES than other places of the US. This tells us that like, there tends to be a lot of geographic heterogeneity in these rich-poor connections. Some areas just do really much better at connecting the rich and poor in the area than others. And so this could be, it could be like an urban-rural thing. It could be the role of institutions. This is what it would look like if you zoom in at a city, and most major US cities have a similar pattern here. So this is Chicago. And these are neighborhoods in Chicago. And you'll find places like Englewood, which has a poverty rate of 43%. And their socioeconomic connectedness score, that's what we call the measure of what percent of below median SES friends are above median SES. Their score is about 9.6%, meaning if you were below median SES, then on average, only about 9.6% of friends will be above median SES. Then you just go north a little bit and you'll land yourself in Edison Park with a poverty rate of only 5%, and their socioeconomic connectedness is about 50%, meaning if you're below median, then about half of your friends will be above median. So it's almost like friending at random in that neighborhood. So even within a US city, you'll find huge differences in connectedness between the rich and the poor. If we look at how does this measure correlate with some outcome like upward income mobility? So upward income mobility is if you take children with parents at the 25th percentile, and then you predict their household income rank for when I think it's when they're 30, you get this measure called upward income mobility. So if you take that and you look at how it correlates with this socioeconomic connectedness, the percentage of above median SES friends among low SES individuals, you get this very strong correlation. Cities like Salt Lake City and San Francisco that have very high upward income mobility also have a very high rate of connecting the poor and the rich. By poor, I mean below median SES. By rich, I mean above median SES. Whereas places like Indianapolis or Atlanta, rank very low on upward income mobility and also rank very low at this rate of income connectedness. So there seems to be some relationship between them, and we kind of want to dive deeper into what that relationship is.
A question.
Go ahead.
So the socioeconomic status, is it like specific to a particular location, or is it like a measure of across the country? Like a high socioeconomic status in Chicago could mean different from a high socioeconomic status in rural Minnesota.
That's right. So I think, am I interpreting your question right, of like, is this adjusted for your state or your county, such that like, yeah, they're compared to them. In this analysis, it is not, but we do have one where we instead look at your SCS rank for area instead. And the patterns look very similar when we do an area adjusted SCS rank. I think one reason why we don't adjust here is that a way to think about this is like, it looks at kind of like raw resources you have access to, because it's looking at absolute income. Like, are you connected to people with a higher rate of absolute income? But we're not normalizing for the total amount of resources in an area. So another way to think about it is you could look at like normalizing, like, oh, within Salt Lake City, I'm going to like define what is high SCS and low SCS based on being in Salt Lake City, and then look at like connectedness between what is higher low SCS for Salt Lake City compared to not. I think it tends to flatten this curve a little bit, but in general, like the same like correlative relationships remain when you do that regional adjustment, if that makes sense.
Thank you.
So we take a bunch of measures of the graph, and I talked to a lot of people about graph measures today. We wanted to say like, okay, well, there's this correlation between upward income mobility and socioeconomic connectedness. But what if we took a bunch of other measures, like the clustering of the graph or spectral homophily or things like poverty rates? Does this connection between the rich and the poor even matter compared to those other things? Does it explain upward income mobility? Is it an important determinant when you put all these other things into play? So we ran a big model where we tried a bunch of these measures. So the goal is, how much variation can we explain in upward income mobility? So one way is you can take a bunch of these graph-based measures, things like the clustering, the support ratio, the degree of people, the inequality number of friends, like the Gini coefficient of the network, things that just use the structure of the network and nothing else. And you'll see that some of them are correlated with upward income mobility. It looks like the inequality measure, it has a relationship with it, but clustering does not. Another set of measures is characteristic-based measures. So things that look at the characteristics of that neighborhood, like income segregation, racial segregation, crime, poverty, trust. There's something called the Putnam Index. So, a lot of this is like harping on social capital, and Putnam Index takes into account like civic engagement and other previous ways of looking at social capital. And racial segregation seems to have a much stronger, negative relationship than, say, like Putnam Index has a positive relationship. But what we consistently find across most of our models is that socioeconomic connectedness is one of the most important determinants of upward income mobility and explains a very large share of variation compared to many other measures when we throw them into many different types of models. So there's something here that says like, there's something being captured by the social network and by rich-poor connectedness that matters for upward income mobility. We're not to the point of being able to make any causal claim, but we can say like there's some important information being embedded in these rich-poor connections about the upward income mobility of an area. So another way we were thinking of looking at this is like, well, maybe it could be people make friends in different places, right? Like maybe the rich people are making friends in college and the poor are making friends in their neighborhood. And so if you look at the SCS rank and the proportion of friends that you make, I should add here that where do we get this data? Well, we observe a zip code for everyone in our network. And so that tells us like which of your friends live in your zip code, which can call a neighborhood friend. And then for many of the people in our sample, we will be able to infer high school and college. And then we can also look at the Facebook groups and pages you're associated with to get an idea of which friends you have, which are church friends or interest friends, like soccer club friends. Like if you and a friend aren't in the same zip code, don't go to the same high school, but you are both fans of a soccer club page, we might call that an interest friend. Whereas if you're both belong to a group that looks faith-based, we might think that you're a church friend. So where do you make friends? We find that users of lower SCS tend to make a higher proportion of their friends in their neighborhood than higher SCS friends. Whereas if you look at college friends, you find the inverse relationship. The higher SCS you are, the higher proportion of your friends come from college compared to your total number of friends.
Can I ask a question here, like generally about using Facebook data, because you mentioned Putnam. So like the reason I'm asking this is like because Putnam highlights that in areas that is high that are high in social capital, generally people withdraw from like activities like watching television. So I was thinking that this could be extended to like Facebook data, and I was wondering if you've seen like any like disparities or unequal distribution of Facebook usage or like number of Facebook per profiles across regions that with high or low social capital. And if there is such a thing, could that like kind of bias the measure? Like we are in kind of like, let's say, overestimating in places with low social capital, or we are underestimating with places like with high social capital, if that makes sense.
That makes sense. In the paper, we have a map of Facebook usage by county and zip code, I believe. So you can look at like how usage rates correlate to like social capital or any other measure. So what we find is we based on census data, we have about 88% of US adults with an account in our sample. Where does the 12% missing come from? A lot are missing on the very bottom end, right? Like we're missing people who don't have a phone, who are homeless, who just are not, like they're too poor to be active on social media. Like, they aren't, like people at the very end of the income distribution or aren't going to be super active on Facebook. And then we're missing like a lot of people on the very high end of the income distribution, people who are, I guess, can afford to just like disconnect from social media and not be active. We don't find that big of a variation across the US. Like we don't find zip codes where there's just like, oh, we only have 50% of adults compared to 90% another one. Like there is some variation, but just not a lot. And we don't find much variation by social capital. So because we have such a large percentage of adults in the US using Facebook, now they might not be like, I talked to a lot of people and they're like, well, I don't have a Facebook. And it turns out they do, and they use it like once every few months, and that's enough for them to be in our sample. So that's why like a lot of these numbers seem surprising, but there's a lot of external validity that in the US, like many US adults have Facebook. For a teenage sample, like we have to use Instagram data because we're just not going to get as high levels of usage and penetration. So yeah, because of that, we feel like we have enough of a sample of all parts of the US and all parts of the income distribution in each area to estimate these. We did do some like statistical like methods to like oversample underrepresented people. Like, oh, if an area has much lower number of high income people compared to what the census says, then we should like overrepresent them in our models. it didn't tend to make much of a difference because we just have such high representation across the board of most areas and most income groups. But it was something that we thought a lot about and tried really hard to make sure there weren't massive biases hiding in the data. When we do that, we're thinking of doing this work internationally, and I think that's going to be a massive problem that we're going to have to address. That just luckily for the US study didn't turn out to be as big of a problem as we thought it would be, but definitely something to be thinking about.
Okay, that's very helpful. Thanks. And like, so just a follow-up question on that, like in terms of like, because if we have lower amount of activity in certain regions, like I was wondering if there is like any differences in like, let's say how much you try to build your social network via Facebook compared to like, what is your actual social network in real life?
Yeah, that's a good question. So people might be like very active and keeping all their friends up to date and getting to know lots of people. And like, for example, in the US South, people have way more friends on average than the rest of the population. And so that could be a problem, right? Of like someone could look very connected and look very connected to the rich because they're just putting all their friends on. And then someone could look like totally disconnected. And it's because they're not very active on Facebook. If they were active, they would have added a bunch of friends that made us think they have high social capital. It turns out kind of the trends we're seeing is that most people who are more active and have more friends, we measure as having lower social capital on average. Like the areas we saw, let me see if I can back up here. I'm going forward. So like this area we saw with very low social capital is the US South. The US South has the highest activity and the most friending consistently across most income groups. It's just like a group of population that people are just very active on Facebook. More amongst the poor, but also even the rich in those areas are much more active than like the rich in the Northeast. And so that'd be an area like we could worry that like, oh, well, if the rich and poor, if the rich aren't active in an area, they're not going to like have those poor friends on Facebook, and we're going to miss them in our analysis. But it turns out like the bias tends to be towards like the Northeast is the area where the like rich are less engaged and have fewer friends, but then they still have more of those poor friends than like the South, where like people have 4 times as many friends, and still like most of their friends, if they're poor, are also poor, and most of the rich friends are also rich. So the bias kind of works against the way the maps turn out. But yeah, I think in some sense you're right that like there are unobservables that we can't correct for because we observe nothing off of Facebook whatsoever at the individual level. And so there's going to be things like that like we can't correct for at all. And you know, there might that might be like working against us in some ways that we haven't thought of, or explaining some of these things for sure.
Thanks a lot. Really appreciate that.
Anyways, so if you just look at like where users are making friends, you end up with this like this pattern of where the poor tend to make way more friends, a higher proportion of their friends to their neighborhood. The rich make a much higher proportion of their friends from college. And then like it's for other groups like church, employer, high school, you know, you get like lower on the bottom end of the income distribution, a little higher at the top, but a little more like smooth than other places. So this kind of makes us think like, oh, maybe there could be like a friend decomposition effect. So what we want to do is we want to break down how much of your network comes from the different, how much of your rich friends are coming from where you're making friends. Like it could be the gap is because all the poor make their friends in the neighborhood, all the rich make their friends at college, and that explains the gap. Another mechanism could be exposure, that I go to spaces where there's a lot of high income people. So maybe all my schools, my neighborhood, my church have a lot of high income people. Whereas if you're low SES, your school, neighborhood, and church are all low SES. And it's just like a segregation problem. If we exposed you to those people, then the networks would equalize. And if it's not either of those two, then the last effect would be friending bias, which is you're in those settings together, you're just not becoming friends. So maybe I make friends from my neighborhood, friends from my school, but and they're fully integrated spaces. Like I have the same number of high SES friends than you, but in my school, the high SES kids don't make friends with the low SES kids, and it's more of a bias problem than anything. So kind of like the three things we want to break down are how much of this gap is because low SES and high SES people make friends in different settings versus the settings aren't integrated, they're not exposed to each other, versus bias that they're exposed to each other, they're just not making those friendships. So again, the empirically observed gap is 37% of the high SES friends amongst the low SES. 37% of friends for the low SES are high SES, whereas it's 78% for high SES people. So that's the gap we want to explain. If you try to equalize the share of groups, so we can do these simulations where we try to like re-simulate what the friending rates would be based on like, so for example, we could equalize exposure by, saying like, oh, well, in your high school, only 10% of friends are high SES. What if it were 50%? And we have the same like friending rates between the rich and the poor? What would your network look like? So we re-simulate under three scenarios, like we equalize the share of friends in different groups, we equalize exposure, and then we can see what this gap looks like. So the first one is you equalize share of friending across groups, then the gap doesn't really change. So there isn't a big driver here isn't that the rich and the poor are making friends in different groups. Like we did see that was driving it, but it doesn't drive much of the gap. It's not explaining much of the gap here. But if you quit exposure, then the gap shrinks by about 50 to 60%. So if we like make it so that the high schools, the neighborhoods, the colleges, the low SES people go to have as many high SES people as the schools, neighborhoods, and colleges and churches the high SES people go to, and they have the same rates of like cross SES friending, then the gap would shrink by about half. So like just empirically, this tells us that policymakers waved a magic wand and fully integrated the entire US across all these institutions, we would expect about half of that gap to shrink. And then the last thing would be equating bias, which just like mathematically, they all have to add up to 1. So like if you equate bias, then the gaps would fully disappear. But like conversely, it says like, if you could wave a wand and make it so that basically people friend at random, like you're in the same high school together, and rather than like having homophily in your friends, you friend at random in your school, then that would reduce about half of the gap as well. So we got to find that like, you can think of the heuristic as like roughly half of the gap in friending is because of exposure, and roughly half of the gap is because of bias. Any questions about that overall decomposition?
Yeah, how do we in the equal exposure? So how do we know what would be the friending patterns like in we are friending people randomly when we have like equal bias, but we are accounting for exposure. How do we account for like similar friending patterns? Like what does that look like?
Yeah, so we assume that the same rate of cross SES friending holds. So like, let's say you have a local Minnesota high school, and let's say that the friending rate between the high SES and low SES kids is 20%. We just assume that it's going to be, we hold that at 20%, but we say, let's equalize the amount of high and low SES kids in that school, and then measure what the new number of high SES friends is, assuming that 20% rate holds. So you just like think of the counterfactual of hold the friending rates the same in all schools and settings, but you change the mix of high SES and low SES people, and then see what is the new amount of high SES friends amongst the low SES, and that's how you get that number.
Got it. So the pattern that remains is the rate at which we friend across the different classes. Thanks.
Exactly. Yep. And then the equate bias, as you said, is like we hold the number of high and low SES friends, people fixed in your school, but we make them friend at random instead of the, we say like, oh, instead of like having a 20% friending rate, now there's a 50% friending rate between the high and low SES. Yeah, so then we see like, oh, what would the friending patterns look like there? Of course, there's no policy that would change one without changing the other, but it's just like an interesting counterfactual to think of. So, why do the poor have fewer high SES friends than the rich? We think it's about a 50% exposure segregation across groups and a 50% friending bias. Both of those are functions of policies that affect structure of institutions and friending behaviors. It's like exposures related to things like zoning laws and boundaries and how we have set up our society institutions. Friending bias we find is if I could go deeper here, I don't have the time. I would love to go into like, we have some results of like explaining friending bias. Why does it vary? How does it vary? But we find it varies a lot across settings. So friending bias is very low in churches. Do you take people in the same church group? They tend to have much more cross SES friending than in a school. And group size matters, like smaller settings, like smaller high schools produce more cross SES friendships in very large high schools. Maybe because it's easier to segregate into cliques in very large groups than it is in small ones. We have all of this data at the high school, college, zip code level publicly available. So if you go to socialcapital.org, we have a bunch of maps where you can look at measures of civic engagement, cohesiveness, economic connectedness, and you can download the data set if you want to play with it. We're currently looking at other countries, but no promises on when that might show up. But we'd love all of you, if you have any projects you can think of, to dive into this data and start using it. And we're hoping that it can be really useful for policymakers or researchers to better understand social capital and economic mobility.
So Mike, can I ask a data question here?
Sure, go for it.
For the high schools, I'm looking at a sample size, it's about 17,000 high schools. And I was comparing with total number of the schools in the US, I think the secondary and combined schools is something about 40,000. So I was wondering, and that's only public schools. I was wondering what's been the sampling procedure for these 17,000?
So what is the sampling procedure of how we determine what are the high schools or what are the
yeah, exactly. So which high schools are basically included and which are excluded of these 40,000 roughly?
Got it. So one thing we take is sample size. So because of privacy, we had to have a minimum size of people in each cell. So I believe our minimums are 100 high and 100 low SES people in each school. So we're going to leave out a lot of very small high schools. At a minimum, they have to have 200 kids, but more likely they have to be more 300 to 500 kids at a minimum before they will even show up in our sample. And also, I guess if they're extremely unequal, if a school is all 100% low SES or all high SES, then they won't be in our sample. Yeah, so that's probably going to be the biggest cutoff we have. The second thing is a lot of our schools are based on Facebook pages, and Facebook has a team that maintains pages and does merges with public data into page data and groups data. So it's an internal Facebook project that tries to maintain a consistent schooling database and prediction for people. So we didn't maintain that. It's mostly maintained by Facebook. So there are schools that may not show up because if you create a new school, it may be too early to show up in the Facebook data because there's not enough people putting on their profile. There's not enough people to create a page for it or something. So we did find, as we dug in, we looked at what are the top schools based on NCES data and the top schools in our data set, and what are we missing out? And we did a lot of manual tuning. I think we manually added schools that we could find in the database that Facebook didn't have. But, we're not going to claim that it's a full sample. And as you said, we're missing we're lopping off a big part of that distribution at the lower end that were just too small to add in our sample. But I'd be surprised if there were any big high schools missing from the data set, because we did a lot of work to try to find every big high school that was missing and try to add it. The college's data should be a lot more complete than the high school one, but there's a lot less privacy issues with the college data set than the high school one, based on the restrictions we were under.
Makes sense. Thanks a lot. And one other question, like for the
Can I interrupt you? Maybe hold a question for the end because we have.
Yeah, sure, sorry.
10 minutes left. All right.
Right. So some other research questions we want to answer. So this is a separate project with a different collaborator, is we want to look at, do these patterns hold through other countries? And how does your network impact spatial mobility or migration, like movement? So like we were holding the like your location fixed in the US project, but like if you're in an area with low social mobility, economic opportunity, maybe you would move, maybe your network impacts that, and how that might impact things like urbanization or the urban rural wage gap. So my collaborator Harshal Sahai and I looked at data in India. India is an area that has a very large urban rural wage gap. It's urbanized very slowly compared to peer countries. And you just have like very unequal incomes by district. And we wanted to look into some of the data why this is. India's Facebook's largest user market is about 400 million users, about 30% of India. A lot of them are young and male. And we observe the hometown or the home region for all Facebook users. And we observe that over time. So that lets us build this data set of users' networks at all periods of time, and then their home region prediction. So we basically have this data set of where are you each year? What's your network look like? And then we can see when people move and understand like how it correlates to your network. And sort of the high level results of what we find are people who are richer and more educated have more social capital, so they have more friends living in rich areas. If you're richer, more educated, and more social capital, you're more likely to be able to migrate to rich areas. We estimate models of migration choice of social networks. And what we find is people are about indifferent between a 10% increase in the wages of where they move and about a 12 to 6% increase in friends in that area. So, you will move to a higher, you'll move to a, you'll be willing to move to an area with a lower wage if you have more friends in that city. And if you add networks to traditional models, then networks explain about 20 to 42% of the migration distance relationship. So most econ models just look at how distance impacts where you migrate. What that effect shrinks by about 30% when you add in social networks. So some of it is like you're moving closer, but it's because you have more friends there, not necessarily because the city's closer. Then we look at things like we have an equilibrium model where we can do things like look at reducing the marginal cost of distance or equalizing social networks. And we find these like very large effects for social networks on total welfare, because better networks mean you can migrate to more areas, make a larger income. I think given we're low on time, I'll just like show a few of these slides, but if you look at migration rates in the home wage percentile, you see that people in India mostly migrate to a district with a similar income to the one they're in. So like those who live with a home wage percentile in the bottom quartile, they move to labor migrants move to an area where destination wage is in that same quartile about 80% of the time. And those in the highest quartile move to one with the similar quartile 95% of the time. Going back to the US study where we looked at what's the fraction of social ties by SES, here we find that for users who have a home wage percentile in the lower quarter, about 65% of their friends live in an area with that are in the bottom quartile of income as well. And it's more like 83% for the highest. 83% of those in the highest income quartiles, friends live in an area in the highest income quartile. So we find this like inequality in social ties measured using home wage and also measured using SCS proxies, like the type of phone they use, or like other data we have. We find that migrants from poor areas, migrants are more likely to come from poor areas, but migrants typically have higher human and social capital. So they're more likely to have attended college, to have more friends, and to have friends who live in richer areas. So there is some like correlational evidence that having social capital matters to whether you can migrate or not. In terms of like looking at what is the impact of social networks on where you migrate and whether you migrate, we estimate a series of models that kind of look like this, where we look at your migration choice as a function of the city characteristics, the moving costs, like looking at the distance, your network, how many friends you have there, the amenities of the city. A lot of this is traditional literature, but what's been missing is that network data. Like they estimate these models, but they have no information on networks, whereas we have this panel of networks. To get a little more causal, we have some instrumental variation where we look at weather shocks. So we look at droughts and floods. And we can see that like a drought might move people in your network from one city to another. And then you causally have more people in a certain city than you would have otherwise. And then we can say like, what is that causal impact of having, one more friend in that city than you would have otherwise. And what we find across a lot of these models are, we find this very strong distance effect. You're more likely to move somewhere closer. But having more friends consistently means you're more likely to move there. And across even instrumental variable models, like we found this, like, again, 10% elasticity of like, you're willing to trade off about a 10% decrease in wages for a 10% increase in friends. The willingness to pay for a friend decreases by your local wage. So if you live in a very low wage area, then the willingness to pay for a friend is much higher than if you live in a high wage area, meaning that like if you're poor, you tend to have a very high preference to migrate to somewhere where you have a lot more friends. This could be explained by needing to have like a social insurance network, or could be explained by like the rich not needing that, or willing to care, they maybe care more about job characteristics. But there is like heterogeneity in like how much your friend impacts your migration choice. I'm just going to end here, which is, where do people get the social capital? Well, a lot of it is college attendance. So we look at the difference between college attendees and non-college attendees, and we see that their social network grows over time. And all measures of social capital, like, where your friends live, do they live in rich areas, do they have a higher proxies of SCS, grows over the ages. The difference between college attendees and not, just that gap gets bigger in college and then keeps growing. It kind of levels out at like age 30, but college attendance seems to have a large bearing on your network and the social capital you have. So just concluding this second paper, social networks are important determinants of migration. It accounts for about 20% of that migration distance relationship. We find that increase in social connectedness can have really big economic gains. In our models, when you equalize social networks across cities, average wages go up by 3% and about 25% for those in the bottom quartile. And one policy lever here is education. College attendance boosts network size, diversity, and social capital by around 20%. I'm going to end there and would love to stick around for any questions anyone has.
Thank you, Mike.
Thank you.
We also have a reception outside, but Mike is here and we're also going to be here. So we'll take this opportunity to ask questions, and we can
everyone pour a drink in my honor.
So it's time for questions, and we can take the extra time for questions. And so, please go ahead. If no one has a question, I actually have a couple of questions. Oh, maybe I'll let Farzam go ahead first. I interrupted you. Please go ahead.
Thanks a lot. Sorry, I asked a lot of questions and I didn't know that's what's the rule. So, so basically, I realize you have a panel data, but the data online is like cross-sectional. So I was wondering if you have any plan to actually like at some level of aggregation, release the panel data.
Great question. So in the US study, we didn't have a panel because we didn't have previous SCS estimates. So we don't look at anything panel wise. There's currently a guy in my group, Drew Johnston, he's replicating the US study, but the panel version, doing some like estimates of what previous SCS might be for people, or like saying like, we'll assume your SCS hasn't changed based on the current estimate. What do we find? I think it's too early to know whether we'll release data. I'd like to. I think it'd be amazing if we can release past data. Also, I'd love to like keep updating the data set every year, but I think it's too early to make those promises. So yeah, I don't think no one's even looked at it, so we don't even know what we'll find. But I think we really think there's we're going to find super interesting things of looking at like, how is SCS changing? Are we seeing shifts? We're kind of currently right now, one big project we're looking at is migration, which is like, we're looking at all worldwide migration and trying to understand how are the patterns shifted in the past 5 years? Has it been influenced by COVID? As climate change changing things? How are like how are like crisis zones like the Ukrainian war shifting patterns? And so we're probably going to release a big migration data set at the end of this year of like all worldwide migration for the past 2 years. So that's kind of what we're aiming for right now. And I think hopefully sometime next year, I guess we'll have a paper on the panel on the dynamics of social capital. Unclear whether we'll like have a good enough data set we feel we're comfortable releasing publicly.
Super cool, thanks.
Mike, I was looking at the paper and I'm thinking of the mechanisms that help the poor get out of poverty or economic mobility. And so I'm thinking of 2 papers. Right? Let's look at, you quoted Munshi's paper. So Munshi's paper about the diamond traders in India and how the lower economic class actually moved up was because of high clustering coefficient. There was a high close-knit community that led them to growth, right?
Yep.
Now, so that was the strong ties, right? Now, the other side, if you look at the Granovetter score, so weak ties actually lead to economic mobility because you are more able to find jobs. But you are not doing either of those. You're doing somewhere in the middle. You're looking at friendships, strong ties, but not the diversity is helping to some extent. That the more diverse relationships you have, the more opportunities you will get. But you're looking at special kind of diversity that you want to have rich people. So what is the mechanism that's driving this? That's not clear in this one, right?
Yeah, I think we don't have a lot to say on mechanisms. Like take your social network. Who are the friends who are like, let's say that we believe the effect that more rich friends lead to more upward income mobility. Why is that? Is it like they're giving me information? Is it they're giving me jobs? Is it they're motivating me, inspiring me? Is it, they're giving me a loan to get me to start a business? Maybe it's like I'm more risk seeking because I know I can fall back on them and I can take opportunities I couldn't otherwise. There's a lot of potential explainers here. So I don't think that we know what mechanism is going on. I think that's something that we need to dive into next. We or other policy makers, other researchers. I think we're talking to nonprofits who will connect people to mentors. And I think the experiment might be, let's connect you to a different type of mentors, see how they help you and see which interventions work. Is it a mentor who's like you? Is it someone who's very successful? Is it someone who's just like very knowledgeable? Who can we connect to in a community? So I think that's an interesting question. Is if you're a policymaker and I could create one friendship, what would it look like? I think there's another set of interventions, which are, what are the types of friendships that help? Like, could you do it through a virtual friend only? Does there be someone who meets you in person? How do they meet you? What's the context? Because it could be that friends that you're assigned to by a policymaker or a school aren't that helpful, because the best friends are ones that you meet in organic settings, like they're true friends or people who there's a reciprocal exchange of value. I think all of these are unknown, and it's sort of, if you can figure it out, then there's going to be a lot of cities and policymakers banging on your door to better understand this. But I think that's the tough part about this work is it's unclear exactly what the policy consequences are here because there just aren't many good policies to help create friendships. Like the residential segregation work, it's like, okay, if moving to a higher income area is better for the poor, let's create housing vouchers for them. Let's move them. Let's build more housing in that area. Or let's like make those areas look like the rich areas by reducing crime and poverty. If it's experience segregation, it's like we need to integrate our schools. We need to get you to college. But if it's just social networks, I don't know, that's more of like what's happening in society. And like we just have much fewer policy levers that we know of to move social networks around.
This also has implications for, say, development economics, right? For the microfinance. So your co-author worked on the Spandan project in India.
Yep.
The foundation microfinance loans.
Yeah.
Like then the cohorts were made with people of the same kind. So should it be that the cohort should be diverse? Like there should be some rich people in the cohort should be guarantor for the loans, but that could have other moral hazard issues, right?
Yeah. The microfinance networks literature is super interesting because you get in these areas, you have places of where people rely a lot heavier on networks for reputation, for loans. That like one example is this, I forgot the name for it, but it's where like people will pool their money in a village every month and then they like draw a lottery or they'll give it to like to someone at most need. And like they have all these super creative ways of social support in that area that were like critically on your social network, right? Like you need to like have a good reputation. You need to know people. If you're cut off from many resources. And so in that setting, I think there's a lot more you can learn about how people rely on social network and things like the network structure, centrality. I just don't know how well that generalizes to other places in the world, especially like to the US. I don't think it generalizes that well, but take somewhere in the middle, like India, where yes, you have some rural villages, but then you have places like Delhi where it's like, do people use their network in that way and how does it operate? I think we probably will find very different effects depending on the country, culture, and setting we go to. Sorry, someone is raising their hand. Kristen Peterson, do you have a question?
Yeah, mine's a little bit less technical or focused on your research, but I'm curious how your group falls inside of Facebook. Like, are you in some sort of social responsibility group, or how does this align with Meta's business goals?
Good question. We're sort of figuring that out. I'm currently in a team called Core Data Science, which lets researchers kind of pursue their passion and try different things. Most people in core data science are working on things like ad auctions or very business-centric things. I'm working with a group called Data for Good, which is about using data to solve humanitarian problems like floods or helping people in a crisis. I'm kind of the only person working in this like social science for good area, trying to prove it out and see if it's successful and we can build out more of it. But I don't think there's many people at Meta or Facebook doing this kind of work. And I think it's sort of unclear yet how this could be valuable for the company. So I think there's some programs like Data for Good where we believe there's value to the world of doing this kind of work and helping policymakers and helping create understanding. But I think given that these things take a long time and the progress and value take a long time to materialize, I think my leadership's comfortable being very patient to say like, let's do this over many years and then let's look back and see like, are we benefiting research? Are we benefiting policy? Are we benefiting society? And hopefully we have many success stories to point to of how people are using these data for good. I guess otherwise they'll fire me, but luckily the launch of the Social Capital Atlas has gotten a lot of policymakers interested. And so we've actually been talking to top Facebook leadership who want to actually build out this area and do more work. Like they're very interested in doing this internationally, of like looking at these things of like, how do people benefit from networks? How do people use their friends for value? So we may end up like building a small, like I'm proposing we build a small social capital lab to study this more and go deeper, and that may end up happening.
Okay, great, thanks.
So on that note, right, thank you for sharing the data. I think that's actually a great resource. And maybe some of the students will actually be working on projects, especially for the class projects.
Definitely. I think both Social Capital Atlas and Social Connectedness Index are perfect class project data sets, so dive in, let me know what you find, and let me know any problems you find. I would love to hear anything you're working on and love to be of help if I can be. Farzam, I think you have your hand up. You're muted. Sorry.
You're muted.
Sorry, I was just wondering if Facebook policy goes around the attempt to making like determining race, because like I was very curious to understand what is like racial income inequality or racial connectedness. So
Good question. We as well desperately wanted to use race because we feel like a lot of these things are racially motivated, or like adding race would give us a deeper layer of understanding of how this works. I think it's clear that there's like racial homophily in social networks, and I think that would explain some of these patterns. Sadly, Facebook does not collect any race data, make any racial inferences. And we're talking to the teams about, can we make bespoke racial inferences just to study racial connectedness and not retain the data, but just to like do it, delete the inferences, but like retain the analysis. The negotiations aren't going that well. It's so sensitive within the company. We may succeed one day, but I don't see any progress in the next year on that front. But hopefully we can. I do feel it's very important. And you join the chorus of all the reviewers of the paper, all the people we presented to, and even Bob Putnam, when we presented at Brookings, he said, like, what can we do to bang Mark Zuckerberg over the head and get him to release race data? I think not only this, but also look at India. Caste networks would be fascinating to study, right? How does like caste impact like social networks today? I think just there's so much we could do. So hopefully one day, I'm holding out hope, but it's not looking promising right now.
Well, great. By the way, I'm using the data as one of my essays. So like as part of one of the analysis, super cool.
Oh, awesome. Yeah. If you have any questions or any like things to add, feel free to ping me an email. I'd love to hear it.
Thanks a lot. Appreciate that.
Okay, so we will end here. Thank you, Mike. Thank you so much for.
Well, have a great reception. Bye-bye.
Back up later.